All right, let's dive right into this explainer. Today, we're making a massive shift. We're moving away from writing those fragile, duct-taped laptop scripts, and we're stepping up to craft robust, production-grade automation. If you've ever felt that absolute stomach-dropping panic of a script failing quietly in the background and taking down an entire server, well, you are in exactly the right place. We're going to break down the foundational best practices that separate amateur code from the kind of reliable, sleep-through-the-night tools that senior engineers build. Look, we all know the relatable pain of a chaotic 3 a.m. server troubleshooting session, right? You're fueled by panic, running on bad coffee, all because a script decided to fail silently. It works perfectly in the cozy, safe little environment of your local laptop, but the exact second it hits the cold, hard reality of a production server, it completely crumbles. It's incredibly stressful, but honestly, it's entirely preventable. There's a fundamental difference between amateur habits and the true senior DevOps reality. Think about the junior mindset for a second. It usually involves manually running commands, painstakingly checking log files one by one. I mean, it's a process that steals 4 soul-crushing minutes from you every single morning. The senior mindset, on the other hand, that's an automated script that executes that exact same task in 2 seconds, completely hands-off while you're just sitting back sipping your coffee. That is exactly the mindset we're adopting today. So here is our roadmap to building that production-grade script piece by piece. First, building your safety net, then variables and secrets. Third, loops as conveyor belts. Fourth, cross-machine portability. And finally, preparing for CI/CD pipelines. Okay, let's kick things off with part 1, building your safety net. If you take nothing else away from today, remember these 3 little letters, E-U-O. We use the command set-EUO pipefail right at the top of our scripts, and not because we just enjoy extra typing. It acts as an absolute safety net against catastrophic bugs. The E tells the script to exit immediately if any command fails. The U loudly throws an error if you try to use an undefined variable. And that -O pipefail part, that actually catches failures that are secretly hidden inside chained pipe commands. The golden rule here is so simple. Fail loudly, not silently. Because without this safety net, a bash script will literally just keep blindly executing the next line, even if the previous one spectacularly failed, like, say, failing to change a directory and then running a delete command anyway. Yeah, that is exactly how you end up with massive, untraceable bugs and production. Right. Let's move to part 2, variables and secrets. I always like to think of variables as labeled storage boxes. You really have to handle what's inside them carefully, especially when you're dealing with credentials, passwords, or API keys. I mean, if you wouldn't leave a box of highly sensitive corporate documents sitting wide open in a public square, you definitely shouldn't leave your script variables unsecured or sloppily defined either. So, a senior engineer populates these boxes using strict best practices. When using plain strings, remember, and this is huge, absolutely no spaces around that equal sign. That is literally the #1 beginner mistake. We also use command substitutions, wrapping commands in a $ and parentheses to seamlessly capture output. And crucially, we use the default value pattern. It looks like $var:\default. This basically tells the script, hey, use this variable, but if it's completely empty, safely fall back to this default instead. It's an absolute lifesaver for injecting secrets safely. But setting them isn't enough. We have to lock down those secrets at the file system level too. We've all heard the absolute horror stories of someone accidentally committing an exposed AWS key and costing their company 50 grand overnight, right? So 755 is your standard permission for executable scripts. 644 is for your standard config files. But 600? That is non-negotiable for secrets and .env files. It means only the owner can read or write to it, period. No exceptions. Awesome. Now for part 3, loops as conveyor belts. Loops are what take your script from being just kind of useful to incredibly powerful. Think of them as a factory conveyor belt. They allow you to process a massive list of files, query dozens of servers, or scan hundreds of logs identically every single time. It completely removes human error from the equation. Let's quickly build up that automation toolkit. Whether you're iterating over a fixed list with a simple for-in loop, auto-detecting log files with a glob pattern, or safely reading a massive file line by line using while read, these structures guarantee consistent execution. Oh, and that C-style retry counter? That is the exact real-world pattern you'll find under the hood of professional deployment health checks. It tries, waits, checks again. Super resilient. Next up, part 4, cross-machine portability. Here is the ultimate reality check that separates a fragile script from a true production-ready automation asset. Will this actually work on your CI/CD runner? See, your laptop is a highly customized, tightly controlled environment. A newly provisioned server in the cloud or a fresh CI runner? Absolutely not. We have to script defensively to ensure our tools work literally anywhere. So how do we do that? By verifying command availability using a really simple path check. This guarantees cross-machine compatibility before your script even tries to run its core logic. For example, if your script relies on a tool like JQ to parse JSON, and JQ simply isn't installed on the runner, doing a quick command-v JQ check loudly fails right away and tells you exactly why. It completely saves you from those mysterious syntax errors halfway through a critical deployment. And when it comes to conditionals, always use double brackets. They are much safer, they're built natively for Bash, and they even support regular expressions, unlike those fragile single brackets you constantly spot in older amateur scripts. Combine those double brackets with powerful flags like F to check if a file exists, or S to ensure file actually has data inside it. This is exactly how your script makes intelligent, context-aware decisions on the fly. Now, an incredibly crucial point when you start building functions inside your script is scoping. Scoping your variables as local is non-negotiable. Seriously, without that local keyword, any variable you defined in a function instantly becomes a global variable, which means it will silently stomp all over global data you might be using somewhere else in your script, creating these bizarre ghost bugs that will make you want to pull your hair out. Just type local. It takes a second, and it saves hours of debugging. All right, bringing it home with part 5, preparing for CI/CD pipelines. All these habits we've been building today, they seamlessly plug right into a CI/CD lifecycle, like GitHub Actions. When an event triggers the pipeline, it injects your secrets securely into the environment variables we set up earlier. Then, it executes the script, and finally, most importantly, it checks the exit code. This workflow effortlessly turns your local script into a hardened, automated pipeline step. But we do need to make our scripts bulletproof for those automated pipelines first. Using the required arguments pattern is a game changer because it allows your script to self-document. That little question mark syntax, it intentionally fails the script and prints your helpful usage message if the pipeline, or let's be real, a sleep-deprived fellow developer, forgets to pass a required parameter. No massive, clunky if-else blocks needed here, just clean, elegant, fail-safe code. And finally, let's talk about those exit codes. Exit codes are literally the language of automation. They are exactly how your script talks back to systems like GitHub Actions or Kubernetes to report its health. A 0, that means everything went perfectly. A 1 is a general error. A 127 means a command was entirely missing. When you explicitly design your script to return the correct exit codes, the pipeline knows exactly whether to give the green light and pass the build or sound the alarms. So, we've covered the strict safety nets, the proper secret handling, the conveyor belt of loops, and the vital pipeline prep. You are now fully armed with senior DevOps practices, shifting from fragile typing to hardened, reliable automation. So the only question left for you is, what manual soul-crushing task are you going to automate into a glorious 2-second script tomorrow? Adopt this mindset, get out there, and start building. Thanks so much for joining me on this explainer, and I'll catch you in the next one.